We're doing problem 2, part B, section 5.1. So this is the functions, same questions as for part A. Find the critical numbers, find where the function is increasing or decreasing. So as usual, we start out by taking the derivative. So here we use the general power rule. We put the 4/5 in front. And then we lower that by 1. That's going to give us negative 1/5. And now the derivative of that inner function is just 1, so we don't even need to bother with that. But technically, this would be a chain rule problem. Let's go ahead and write this as 4/5. Now, that 1/5, since it's negative, that's what puts it in the denominator. So we're going to get x plus 1 to the positive 1/5 power down there in the denominator. Okay, so we want to set that thing equal to 0 to find the first kind of critical number, but really remember that the easiest way to think about finding these critical numbers is to set first the numerator equal to 0 and then the denominator to 0. So notice if I try to set that numerator to 0, well, nothing happens. 4 equals 0, there's no solution. So there are none of those type 1 critical numbers. That is where the derivative is equal to 0. So really the only other kind that there is the kind that we get when we set the denominator to 0. And that would be where the derivative is not defined. So if we do that, we can divide both sides by 5. So we're going to get x plus 1 to the 1/5 is equal to 0. Now, to get rid of that 1/5 power, I just raise both sides to the 5th power. And of course, 0 to the 5th power is still 0, and then those are now going to cancel. So I'm just left with x plus 1 is equal to 0. And so what does that tell us? That x equals negative 1 is a critical number. Okay, and that's the only kind. And remember, this is like a type 2 critical number, the kind where the derivative doesn't exist. So if we graph this function, what we would find is that there would be a sharp point in the function at negative 1. Okay. Now to answer the question about where it's increasing and decreasing, we have to still set up our intervals. So really, there's only 2 intervals to worry about now. Minus infinity to minus 1, and then minus 1 to infinity, since that's the only critical number. Otherwise, this is the same process as we had done on the last problem. We find our test values. We check the sign of the derivative. We draw our conclusions from there. Okay, so let's pick 0 for the test value here. It's on the interval. Let's pick, oh, I'm sorry, no, 0 for the other one. 0 is on that interval, not the first one. Let's pick negative 2 for that first one. Get rid of that. Okay, so let's pick negative 2 for this one. Okay, so now we come back, and remember we have to plug these numbers into f prime, into the derivative. So if I plug in, let's say, negative 2 to that derivative, here's the derivative here. If I plug in negative 2, I'm going to get negative 2 plus 1 is a negative number. If I raise a negative number to the 1/5 power, remember what that is, that's a 5th root. The 5th root of negative 1 is itself going to be negative 1. Remember, it's okay to take an odd root of a negative number. So we will get a negative value once we plug in negative 2. If I plug in 0, I think it's pretty clear what's going to happen. Basically, all I'm going to get is just 4/5, which is a positive number. So what matters is just the sign. So the function is decreasing, and then it's increasing. And so our intervals for part B on this problem, where is the function increasing? It's increasing on the interval from negative 1 to infinity, and it's decreasing for part C on the interval from negative infinity to negative 1. Okay, we'll do part C on the next video.